Hi everyone, welcome to Get More Out of 3D Printing with Figure 4, Speed, Precision, Flexibility, featuring MasterGraphics. My name is Tess Smith and I will be your moderator. Just a few housekeeping notes before we get started. At the bottom of your screen, you'll see a section for Q&A. Please use this section to ask any questions. We'll be answering your questions at the end of the presentation and we will do our best to answer as many as we can. Any questions we aren't able to get to will be sent to an expert who will reach out to you directly. Please note this webinar is being recorded and will be available soon. I'd like to introduce you to today's speakers. Barbara Miller-Webb, Additive Manufacturing Business Development for MasterGraphics, Kevin Marchant, Solution Specialist from MasterGraphics, and Kevin Su, Advanced Application Engineer from 3D Systems. At this time, I'd like to hand it over to Barbara to get us started.
Thank you, Tess. Welcome, everyone, and let's get started. We have a lot of information to cover today. So you might ask, why the Figure 4 solution, right? Well, first of all, it's because it's very versatile. It offers what they call digital light printing, DLP, as I may refer to this throughout the presentation, which are solutions that are really designed to scale with your production as your business grows. Seamlessly, you can go all the way from prototyping to production. With the Figure 4, we use a projector-based imaging to quickly form each layer into a single image with your enhanced speed that you're going to see, non-contact membrane technology, and the print speed really is complemented by a light-based UV curing process that takes literally minutes versus hours, with a heat-based curing process to give you that fast throughput and really just the time to part. So one thing you're going to see is that this is truly repeatable, true to CAD, and it is accuracy with Six Sigma repeatability. Something to note here, if you look at this screen, you're going to see the Figure 4 allows you to do low volume production up to 500 parts per month, whereas the Figure 4 modular, the next step up, it's scalable, semi-automated, and it's a production solution for prototyping and bridge manufacturing up to 10,000 parts per month. Look at the last one. That's our Figure 4 production series. That is fully customizable, fully automated from entry to post-processing for direct production of parts up to 1 million parts per year. Next. So what is the Figure 4 Standalone? First of all, it's an affordable solution that really gives you that lower cost production. You can do functional parts, low volume production runs. You're gonna, again, with the Standalone that we're focusing on today, you can do outputs of 500 parts per month. You're gonna get that quality, accuracy, high speed, you guys. This is the highest speed out there really in the market today, with up to 3 different print modes and 100 millimeters per hour. Next. I just want to show you a video here, but again, the whole point is I really want you to focus on what the point of this Figure 4 is. Saving time, which at the end of the day is what we're all looking for in manufacturing, and costs of tooling by giving you a reduced part cost, faster time to market, and increased flexibility. Let's take a look at the video. And again, I don't have, this is just music in the background. I just want you to take a look at this. We're going to go into more detail with Kevin Marchant. He's going to be showing you in person the actual printer itself. So this is just kind of a preview. Okay, next. The other thing that you're getting out of this, as I mentioned previously, is it's accurate to Six Sigma. This is a great representation of the accuracy and repeatability that you get time after time with this Figure 4. Next. 3D Sprint is the software that comes along with all of 3D Systems solutions. The nice thing about this software is you're strictly going to take from your CAD solution whatever that is, Inventor, SolidWorks, whatever it might be, bring it into the software. The software is so user-friendly, and you're going to see this with Kevin Sue coming up here shortly. But this is where you prepare the file, you edit it, and get ready to print it. Next. I want to talk a moment about Figure 4 materials. So really, what's different about the Figure 4 production grade materials? Well, you know, if you think about it, there's been a major stigma out there on additive manufacturing materials, thinking that they were very brittle, only have reliable mechanical properties really for just a short period of time. But in all honesty, those perceptions have posed a hurdle to adoption. And that's something that the 3D printing industry has struggled with for several years. But now that there's been advancements in the part quality, the speed, and the cost, we're really moving additive manufacturing technologies beyond prototyping into production, which is really necessary for all additive materials to level up as well. So 3D Systems has actually ensured that data integrity with all of the Figure 4 materials by testing and conditioning per the ASTM and ISO requirements. Next. I'm going to just kind of cover the portfolio, take a look at all these material options within the Figure 4. And I've broken them into 3 categories: prototyping, production, and application specific. So this really does open up innovation of new materials that are open up into production workflows for digital manufacturing. A new class of these materials, which actually has industry-leading UV stability, and that's something I want to really point out here. And I'm only going to highlight a couple of these right now and then go dig deeper. Take a look at the Tough Black 20, which is in the prototyping box. That's really the highest precision prototyping material. It's got great UV stability for production applications. If you take a look at the Temp 300 AMB, that's in the production box. That is super for high temperature resistance in the harshest environments that you might be in. Last box is the Rubber Black 10. This is a high tear strength, malleable material for hard rubber-like products. Next. So again, like I said, I'm not going to be able to go into all of them in great detail because otherwise I'd be here for a lot longer, and I'm not sure you guys may have that time. But let's just focus a moment on the Tough Black 20. Again, this is a strong plastic that simulates injection molded ABS. It's got a long-term environmental stability for high performance prototyping, but also production parts. So let's not forget that. You're still going to get that precision, smooth surface capability. Next. And I think that's highlighted here with the charts that you're looking at. That top chart refers to the outdoor weathering stability. This, if you take a look at the top part of the chart there, you're going to see that that's the Figure 4 and how it's really weathered all of this. Take a look down below. That's your traditional UV cured material. This is over a 12-month exposure. And if you notice, it is performing consistently for a long period. Go down to the bottom actual of that, and that's the indoor aging stability. That's over a 5-year exposure. So again, this really shows you that the exposure, whether it's indoor, outdoor, of plastics, from radiation through a window or whatever, it really holds up nicely. Next. This is our Flex Black 10 material. This really allows you to produce the toughest 3D printed part with nice durability for prototyping, but also maybe testing, functional testing, or maybe even low volume applications. It's going to give you great flexibility and accuracy, but, and I'm going to show you in a video here coming up, again, the thing I want to point out, long-term environmental stability, something we don't necessarily think about. Stability that's been a big hurdle for additive manufacturing. Next. So this is a video that is going to show you a little bit about how durable this Black Flex 10 material is. And again, it's going to be something I'm going to talk you guys through. So first of all, this is the first impact strength test that we did. Number 1, it was 6mm unnotched. And you notice it did not break with that impact. This is the second test we did. This is a 3mm unnotched. And again, did not break. Again, this is just a great testament to this material. It's durable, impact resistant, polypropylene-like, great elongation at break at 104%. So just another great material on this Figure 4 DLP, digital light printing capability. Next. Let's talk a moment about the High Temp 300 Ambient. I love this material because it's ultra high temperature plastic for applications that really do require that high heat resistance. So right now, it's actually the industry's highest heat material. It's got a heat deflection of 300 C, and that's whether it's at low or high stress, doesn't matter. The material's great for testing components like in HVAC, maybe consumer compliance appliances, maybe motor enclosures, molds, and things of that nature. Next. The rubber black tin, this again is a high tear strength material, great for the production of maybe grips. You might be doing handles or bumpers, as well as maybe from something from a strain relief application if you're trying to do overmolds or couplings. This has got a slow rebound, as you saw, but again, it's a great material with exceptional surface and long-term environmental stability. Next. This is probably, I call this something that's maybe hidden or maybe not talked about as much as it should be, but I love this material. If you guys are trying to do sacrificial tooling for casting of silicone parts in any durometer, this is it. It's really designed to withstand liquid silicone injection at a high temp and pressure and still have that brittleness to be able to shatter easily from silicone once the mold is actually filled and then cooled. The beauty of it is that amber color, it allows for visualization of the injected silicone. And it also has a high heat deflection temperature that you certainly need. Next. I want to go through some applications, some print times, build times. So let's take a look at the next screen. Again, I'm going to do a summary. This is all of the applications. There may be more, but certainly this is the bulk of the applications that you can do with this Figure 4. Like we just talked about, cast urethane process. If you guys haven't thought about that for your processing of your manufacturing, you really need to consider it. This is a huge time saver, money saver process. But you can also use this technology for end-use durable plastic parts, medical applications, jigs, fixtures, molds and patterns. And with the elastomer material or rubber-like material, you can use it for overmolds, seals, and grips. Next. This is something that Kevin, Sue's actually going to talk about when we talk about 3D Sprint, but the beauty of being able to do digital part texturing. What is the benefit? It avoids tool etching delays, right? And it's labor intensive when you think about it in the post-processing. So being able to do this in the software really gives you that excess throughput that you're looking for. Next. I want to dig into the time. I talked about speed, and I mentioned this is the fastest technology, I swear, out on the market. This is a pilot knob. It's a remanufactured part for obsolete legacy parts, but I want you to look down at the bottom where it talks about build time part. 6 minutes and 50 seconds to print this part. If you go put that in other technologies, I'm sorry, but there's no comparison. And $1.08 per part. And if you do 7, it's 48 minutes. Think about that, being able to come off of the production with a part in your hand. Next. Another good example, electronic slider case. Now this is 2 parts. This was not printed in one, 2 separate parts. But notice that you've got to have high accuracy, right? If you're going to slide 2 parts together, and this is a great example. Again, check out the time, 8 minutes for one, 3 minutes for the other. Next. The last is the rubber-like prototypes. that in this case, it's actually a bumper plug. Again, I just want you to check out the time, 6 minutes build time per part at $1.60 per part. Doesn't get any better than that. Next. Biocompatible medical devices. This is a water nozzle. Something that I really would like to accentuate here is the fact that you do get crisp details, but they can be sterilized and tested at over temps of 100°C. Look at the build time on that. For one of the materials, the white, and then the other for the ambient material. Next. So this is a customer of ours, Rapid Application Group. They're a service bureau, and I just want to point out that they were able to produce, with the Figure 4, injection molded surface quality parts in much shorter lead times than they ever could before with their other technologies that they had in-house. In addition to the ease of operation and the ability to produce fast parts at a low cost, it really paid for itself. So the ROI was great in that it doubled their capacity for high quality small parts in just a few months. Next. This is another good example of check fixtures that they did. You know, their challenge was trying to get those check fixtures out for aerospace customers in a very fast turnaround time. Total time, parts in their hand, 91 minutes. Think about how happy your customers would be if you were sending that to them, or in your case, maybe out to your production floor. Next. Eggshell molding. Again, I cannot stress how key this is. This is a customer, ACS Custom. Their challenge was being able to get production capacity for in-hearing protection devices. They did it with the Figure 4. They were able to reduce their material consumption by 50% and, more importantly, man hours by 80%. Next. 3dprintedparts.com. In this example, again, just another example of how they were able to do a replacement of injection molded quality parts. Next. So 3 things I really want to hope that you guys took away today, more importantly, is the fact that this is some of the fastest technology out there on the market, huge cost savings, something that is not even comparable. Materials, we talked about 13 different materials, and trust me guys, there's going to be a whole lot more than that. 3D Systems never stops with their material advancements. But lastly, versatility. You saw so many different applications, from eggshell molding for silicones, cast urethane, all the way to prototyping. So hopefully you got that today, and I appreciate your time. And I'm going to turn this over to Kevin Marchant so you can see the actual real live demonstration of the machine itself.
Thanks for that warm introduction. Again, my name is Kevin Marchant with MasterGraphics, and today I'm going to show you and talk a little bit more about 3D Systems Figure 4 Standalone DLP printer. As explained, this printer is an open bath system. In other words, we take a bottle of material, and after we've mixed it up, whether we've shaken it or rolled it for an extended period of time, then that mixes this print material up well. We take that material and we simply pour it into the bath, depending on how big our prints are, how many prints we're making. There are some level guides back here to help us decide that level of fullness in here. The way this printer works, it's got these arms. It's going to drop down, and then as it prints, it literally pulls the print out of the bath. It's kind of fun to watch, especially on the fast draft mode. It's very impressive. From here, we would remove that print, and I'm going to show you this process, but we're going to go through 2 different open baths of isopropyl alcohol, or IPA, as most of us call it, to deal with it on a regular basis, because it's kind of a mouthful. And before I do that, I'm going to put on some gloves out here. So we can go through both baths. One is a dirtier IPA, meaning it's been used before. That's going to help me remove the surface tension printing material from my solid printed part or parts. And we're going to do this simply by using some provided tools with our printer to physically push the print off of the print carriage. So we can come over here, get that ready. Normally I would wear a mask, but it's kind of hard to hear with that on. So hopefully everybody can hear me okay. This has been dripping overnight, and I printed it yesterday afternoon, last night, and so now we're just going to get a little bit of that excess. And what you're seeing is this has some pockets in there. So geometry dependent, you may have more time needed to get rid of the excess print material at this stage than others. Again, I had to break some surface tension in here by changing the angle in which the part came up because it has some cavities that created a vacuum. Those guys look big enough. So now I'm simply going to come over here to my first IPA bath. I'm going to grab my pusher tool. It's got pegs that line up with the holes. I don't know if you can see that. And that allows me to simply come in here and push that print off of the print carriage. This is tough grade material. I'm not concerned at all if I drop this part into my bath other than the splash effect. I use a nice tall tub to keep that from happening often at all. Pop those guys off. Simply going to set this guy up there. And then I'm just going to reach in here and I'm just going to swirl them around a little bit in my IPA. Now again, this is the gross removal stage. So I'm just going to swirl these guys around. I may even come over here and grab my paintbrush just to help scrub on that a little bit. Just to get as much of that surface tension material off of there as possible. And I know I've done this well when I'm done with my part through the whole process because then it's not shiny. Also at this stage, what I want to do is use my provided knife scraper that has a beveled, sharpened edge. It's not so sharp it'll cut you unless you try really hard. But what it's going to allow me to do is come in here in the bottom of my part, and it's going to allow me to easily and quickly remove that support material that attached my print to my print carriage. Depending on the surface that I've got or how much is left, I may even come back and scrape that a little bit more. Depending on my part geometry, helps me decide where I'm going to put my support and where I'm going to attach my print to my print carriage. And I believe that we're going to see that shortly with the 3D Sprint software review. It's super easy, super quick, and very intelligent. Seals in there nicely. Then I'm going to switch over here to my number 2 bath. This bath is much cleaner IPA. This is going to allow me to get my part just the next step cleaner with that material. Again, just using some finger tension, scrubbing on this. Again, I'm going to bring my brush in here. Second, these guys reached out. I can look at that, and what I'm looking for is just any area that I haven't previously noticed that is otherwise still has material or has any support attachment points left on it that I don't want. And when I'm happy with that, then I'm just going to set this aside. Different materials want different drying times. Different geometry is going to require a little bit different drying time. But as a general rule, we're going to let that sit for about 90 minutes to air dry. Just going to cover these guys in there. So one of the beautiful things about this printing system that we have is the simplicity of use. So we've got an open bath, means that I know exactly how much material is in there to run my print. We've got a system that comes with multiple plates, so I can come over here to my next carriage can simply set that in. The system itself is robust enough. I don't have to worry about balancing or leveling any of this stuff out. It's ready to go, which means if I've got another print, I'm off to the races. To do that, I simply come in here. I could say reprint on this screen. I'm going to scan my bottle of material. It's going to ask me some questions out here. It's basically going to say, hey, do I have a clean platform? Yes. Did I stir it? Yes. Is it filled enough for my print job? Yes, yes, and yes. And then I would say start job if I wanted a second set of what I've got. If I don't, then I simply come out here. I don't put in a new carriage. And what's wonderful, another beautiful part of this system is it comes with what's called a garage. And that means I have a place to park my material when it's not in use. So if I'm not going to print for a while, or if I'm done printing in gray for today, and the next material I'm going to load is another tray with white material or rubber-like material, then I can simply load that up and store my non-in-use material in the bottom of my printer, load up my next material, or I can simply close this guy down. Once my parts are dry, I'm going to bring them over here to my UV station. I'm going to place them in my UV. Our next dent UV has a built-in timer in here, so I'm simply going to say start. Starts counting down from 90 minutes, which is the most average material curing time. Run silently until it's done. So hopefully this gives you a good overview of the Figure 4 system.
Thank you, Kevin. We are now going to turn it over to Kevin Sue to provide a 3D printing demo.
All right, so I'm gonna go through a demo of 3D Sprint. I'm gonna talk a bit about how to get started with printing your own parts, and along the way, I'll provide some best practice tips to ensure quality prints. So first off, we can set up our printer and our materials and build style. So first off, we have our printer here. In this case, I'll be using a Figure 4 Standalone, but as you see, we have a lot of printer selections for whichever machines you may have. And then material selection here. In this case, I'll be using Pro Black 10 as it's a well-rounded general use material. And we have layer resolutions and build styles. In this case, I'll be using 50 micron and standard. If I want to print faster, I can always use draft modes. And if I wanted to have a better print quality, but a little bit slower, I'll go premium. There's also some build styles for thicker cross-sectional parts, and for certain orientations. So first things first, you have to bring in your part. So in this case, I'll be importing this part right here. And you'll also want to determine what the intent of your part is. For this part, this is a cover with 3 tube inserts, and there's also a locating feature for a sensor on one side. Now, first thing would be to orient my part. So if I go to orient and I press on auto, in this case, for surface quality, it will place it upwards like so. And there are times when this works really well, but in other cases, you also want to check for sort of like the overall thickness of the cross section as it's printing. So if I go to view and I go to my clipping for Z, and I drag the plane up, you'll see that it goes from a thicker cross section to a very thin one. And usually that causes a lot of print defects, differential shrink, and potentially delamination during the print and after the print. As such, I'm actually going to orient this myself a bit more using the transform tool. And if you click on the edges around here, you'll be able to select and drag and rotate your part. So in this case, I'm gonna sort of angle it like so, as orientation. And with this orientation, it'll allow me to fit 2 of these parts also on the platform. So once you have your orientation somewhat set up, you would select your part and click on Smart Support. And so we have some presets. Fine flat tips works for most parts, and especially for this material. In this case, I will click on Create Supports, and it'll auto-generate supports for me. Now, as you can see, there's it sort of determined that some faces were a little bit at a steeper angle than, and so it supported a lot of these surfaces. And knowing that, I actually will reorient this part a bit more. So I'm gonna, because these are actually somewhat self-supporting, given you have some supports to at least start the print. So if I go to Smart Supports again, I'm gonna create supports. I'm able to remove some of the supports on this side and reduce the amount of supports on the inside of the part. And there's also, there are some supports placed onto this locating feature for the sensor. I'm actually going to remove some of this because you don't want any supports going on that part. And I'm also going to remove some from over here. And if I were to update my supports, I have a fully supported part. And now if I want to make multiple copies to fill in that platform, I can go to copy function, either fill out the platform or select a specific number, or do linear pattern to set those values. And after you have this all set up, I would highly recommend saving your file, your 3D Sprint file. In this case, I would just save it. And then you would print to file. Now, if you had a local printer connected already to 3D Sprint, you can instead of selecting a virtual printer, you select that local printer, and you would also have a button here that allows you to send directly to that printer. But in this case, if you print a file, you'll save it as a pixel or a F4X file, and then you'll go to the queue. Here it will list all any connected printers, and then you'll be able to select that printer and add the file, and add that file that you created. Now, 3D Sprint's not only just a bring in your part and send it directly, create supports and send it to your printer software. It's a lot more than that. It's a powerful tool that allows you to, if you go to prepare tab, you'll be able to reduce your triangle count, fix your parts up. So in this case, I have some intersections of these faces, and then I can actually fix the parts up, fix the mesh up. You're able to mirror your parts, offset, hollow them, thicken them. You'll be able to split, extrude certain faces, and you'll also be able to engrave your parts. So this engrave tool is actually pretty useful if you wanted to label your parts. If you're doing a test and you needed a couple of parts labeled very quickly, I can go to engrave, put in a text, and apply. And this will sort of create that text onto that part. Now, there's also a couple other features that I want to show. Some of them are sort of sneak peeks, upcoming features that are not released yet. Now, one of them is industrial stack printing. So for industrial stack printing, it's a feature sort of that I worked on a little bit, and it's a production workflow aimed at printing large quantity of of one single part by utilizing this full platform and the Z height for this figure 4. In this case, I'm using a modular because of that much taller Z height of 350 millimeters. So first things first, you have your part in, or a assembly of parts, and you click on create stack. If you input specific values, you'll see that there's blue and red, shows what fits in, what doesn't, and I can also set a base. And this base will be directly connected or directly printed onto the platform for adhesion. And in this case, I can actually move my parts in a little bit to make sure I can fit more of them onto a platform. Click on set, create a whole stack. Now, if I, so there's an easy way of creating supports, which is smart supports. However, you won't have much control over those supports, especially with the supports going on top of parts. So we've added something a little bit different with struts. The struts, if you create a strut, which is like a point-to-point creation on your parts, and if you create it between your first and second row of parts, you'll be able to generate these custom supports, and they will get replicated throughout your whole part, and even on the bottom. As such, this is more of a manual process, but and as such also a more of an advanced workflow, but it is aimed for those production workflows where you need to print a couple hundreds of parts or thousands of parts, and you don't want to have to print one row of these parts and have to print it like 50, 100 times. Instead, you can just do it 5 or 6, 7 times. There's also another tool that Barbara mentioned earlier, which is sort of our texture tool. In this case, you can apply a noise to a surface. In this case, if I wanted to just select this surface right here, I can apply sort of a noise texture onto that surface. And you sort of have a little more control over selection tools if I want to select more of the part or less. And that's sort of my quick demo on 3D Sprint and sort of how to get to make sure that you can get quality prints and some new features that are coming out soon.
Great. Thank you so much, Kevin. We will now open the remainder of the webinar for Q&A. As a reminder, if you do have a question, please stick it down in the question section and we'll get to it. So the first question we have a lot of good questions coming in. The first one is, what is the operating temperature for the non-high temp materials? Can it be used at 100 C or up to 125 C?
So I think you're probably referring to the non-high temp. Is that what you said, Tess? Okay.
Correct.
So those you should be able to operate up to 100 C.
Perfect. Next question, is there a plan in place to release a build platform that is solid and not hold? I think he's referring
Honestly, yes, to the build platform. At this point, I don't know that there is, Kevin, unless you know something different.
As of now, I don't think so. And that's just sort of, I think it's something we're sort of looking into, but at the moment, there's only one with holes to allow for that fast print speed on the figure 4.
Okay. Next question, are there any clear transparent materials available for figure 4? Do you have a transmission spectrum for the amber colored resins available for post curing?
So right now, the Ambient is the clearest that's available, and I can probably, if they want to email me, feel free to, and I can probably get you the other data as well.
Great. Next question. I see most materials on Figure 4 are long-term indoor and outdoor environmental stable, but which materials are best for biocompatible medical applications?
So actually the Pro Black 10 that I talked about, the rubber material, the rubber black 10, as well as the Ambient 10 and Med White 10. Those are all best for biocompatible.
Perfect. Next question. Have you experimented with printing silicone-based elastomer parts?
Yes. And I can probably try to get you some more details on that, again, if you want to email me.
Okay, and I'll put Barbara's email information in the chat for you guys to email. Unless, Barbara, did you have it up on the spread, the PowerPoint?
You know, I did not, so I will, okay. Yes.
I'll
we'll
put it
that
in the chat. Question, with high temp 300 amber, is there any post-cure process to be performed?
No, as a matter of fact, there's no secondary thermal cure that's required. You know, and like I mentioned before, it's really got great visualization for internal features and if you're trying to do any kind of fluid flow performance. But no, there is not.
And I actually can answer this one. Will you provide a copy of the presentation? We will have a recording available in the next few days for you guys to review. So you guys can look out for that in the next few days. Right. Just check in to see if there are any other questions. And I believe that is it. I want to thank you guys for joining us today. We hope that this information has been of value to you. If you did ask a question, or if you do have a question that wasn't answered, we'll reach out to you shortly. And thank you, Barb, Kevin M, and Kevin H, for sharing all your expertise today. We really, really appreciate you guys taking the time. And we all hope that you enjoy the rest of your day today.